So today's topic is how to become a good backend engineer. Fundamentals. Shall we start? Yes, we are starting in a second. Okay, how to become a good backend engineer. Fundamental. A good I have been a backend engineer for over 18 years, and I witnessed technologies come and go, but one thing always remained constant. The first principle the tech is built on. I don't really mean tools, frameworks, or even language. Those evolve and change, but the fundamental infrastructure on which these tools are built really does. For example, knowing how to set up Apache or IIS is one thing, understanding the commonalities and difference between the two web server is another. In this article, I will explore some of the fundamental of backend engineering that are the root of the everything we use. You may choose to have a basic understanding of all these fundamentals and become a jack of all trade backend engineer and go vertical in the deep level of the and become expert in that area. There is no wrong or right. It depends on what move you. The way to become a better backend engineer is never clean and straightforward. In fact, it is meshy. It is full of trial and error, experimentation that's only you have to experience. There is no book, no course, no YouTube video, no Medium article, and that can teach you everything there is about backend engineering. You have to experience it yourself. If you recently graduate interested in backend engineering, you have to find one or more of these fundamental interesting and decide to pursue it. The best way to get handy dirty, let us get started. Communication protocol link the front end to the back end. Understanding how protocol work is a good skill to have for an engineer, especially if they want to build a silent backend application. Almost all the protocol we use and love on the backend are either built on the TCP or UDP. That's why understanding the difference between the two help to engineer make the right choice. For instance, TCP is a stream-based connection-oriented protocol, while UDP is message-based and connectionless. TCP provides reliable delivery at the cost of connection setup and retransmission, while UDP starts faster but doesn't have guaranteed delivery. Anything you build on the top of this protocol must adhere to their fundamental properties. TCP is not better than UDP and UDP is not better than TCP. It depends on what you are building. Moving up the stack, the HTTP protocol why origin we build on the top of TCP because we wanted to send request and response reliably. Rather, as the web involved and resources become richer, one connection was not sufficient to concurrently send messages multiple requests. So browsers started to establish more and more connection. The cost of connection setup of each request become so high. HTTP/2 introduce application level stream, so multiple requests can be sent on the same connections. Later, HTTP/2 involved and had to be rewritten the top of UDP with HTTP/3. So to solve the TCP had offline problem. There are reasons of everything. The fundamental feature of TCP was culprit of this move. It doesn't mean TCP is bad, and the say BAV has evolved in the way that TCP is no longer suitable. If we didn't know how TCP work, we would not have improved the HTTP protocol. It is also important to know that the using any protocol come with a cost, especially by building APIs. Understanding that cost will help you make better informed decision. For example, using HTTP/y2 might give you HTTP request throughout, but the work the application need to do assemble the stream text and the CPU, something lucid child learned that the hard way. Sometimes the backend architecture require real time bi-directional communication protocol to build chatting, gaming app, or just communication between two service. Protocols such as WebSocket, gRPC, or just raw TCP/UDP can be used if you know how a protocol works and what is the strength and weakness. You will know when to use it. Ultimately, learning communication protocol is important for a backend engineer, and it is possible to go as deep as design in any protocol. Maybe one day you will write an RFC proposing a new protocol. Web servers. Web servers are becoming increasingly important as backend infrastructure really relays On HTTP web communication, web servers deliver static or dynamic content served on the top of HTTP protocol. If you build a web API, you may spin your own web server in your language of choice, or use a web framework such as Express or Django. Modern web servers support both HTTP slash 1.1 and HTTP slash 2. HTTP slash 3 slowly getting supported as a new protocol. Configuring your web server with appropriate protocol is critical for performance and resilience of your backend application, and it depends on the environment. For example, do you expect multiple concurrent requests from the same client, or do you want expect fewer requests but from many clients? Based on that, you can pick multiplexing HTTP slash 2 or vanilla simple HTTP slash point 1. The internal architecture of web servers can also differ. Web server can be single or multi-threaded. They can have one thread or multiple listener threads. There are many ways to client connection can be expected and distributed among the thread. If you choose an of the self web server, you are stuck with the architecture. If you build your own from scratch, you get choose to architecture that is right for you. I wrote an article going multiple design of threading and connection management and backend. You may find, check it out. Additionally, web server can set any where in the stack. For example, a CDN is a web server that act like a cache and communicate with the origin backend web server to get the content. And API gateway is a web server that authenticate user and serve API responsive from backend web server. For examples of the cell web server are Apache, Tomcat, Apache, HTTP, and Nginx. The latter can act as a both web server and proxy. You may build your own web server in a language while listening a TCP port. Understand how I speak HTTP protocol. You can code a HTTP library that does most of your work for you. Database engineering. Database engineering is a vast field of study. As its core, the idea of database simple allow multiple users to store and retrieve data constantly durable fashion. That's why understanding for properties of asset, automaticity, consistency, isolation, and durability is a fundamental of database engineering. That's for all today. Database engineering. Database engineering is a vast field of the study. At its core of idea of database is simple. Allow multiple users to store retrieve data consistently and in a durable fashion. That is why understanding the four properties of asset, automaticity, consistency, isolation, and durability is a fundamental to database engineering. One must understand that nothing is written on stone, and following these properties it must. For example, relational databases are fully asset and require a schema. With MongoDB was built on document based with basic automatically no schema. Redis built on fantastic high promise cache. Why sacrificing durability by default? No database No database system is complete without indexes, and at their core we plus tree data structure of how data is organized in tables, document, or graphs. All data file system pages and the day understanding how to get most of the disk IO read is core of data engineering. If if you are interested in database engineering, there are many areas can specialize. You can pick one database and know everything about it. You can build on better indexing techniques. You can build a new database system specialized in specific workload. I have been working with database for 20 years and do this learn. I learn something new all the time. This field is vast. Proxies are becoming increasingly popular in the engineering world. Especially with the introduction of microservices, the main purpose of the proxy is to receive request from the client and forward the request to backend servers. The proxy hides the network layer and the identity of the original from the destination server. There are two levels of proxying: layer 4 and layer 7 proxying. Layer 4 proxy work at the transport layer, while layer 7 proxy work at the application level. Every layer provides different capabilities and kill with different purpose. Layer 7 proxying require the proxy to understand the application protocol, while 4 proxy protocol will network at the transport layer TCP. Here the forward proxy and reverse proxy interchangeably forward. हाँ जी. That's for it today. I will record it again tomorrow. Thank you. So today's topic is how to become a good backend engineer. Fundamentals. Shall we start? Yes. We are starting in a second. Okay. How to become a good backend engineer. Fundamental. A good I have been a backend engineer for over 18 years, and I witnessed technologies come and go, but one thing always remained constant: the first principle the tech is built on. I don't really mean tools, frameworks, or even language. Those evolve and change, but the fundamental infrastructure on which these tools are built really does. For example, knowing how to set up Apache or